All of the processes we have discussed so far are either started when we boot the system or when we run a command. In this video, we will discuss how you can schedule a process to run at a later time, whether that be at a specific time on a specific date or whenever the system boots. While system administrators are the primary users that schedule processes, normal users can and do benefit from using them. Processes can be scheduled to execute at a specific time using cron. This schedule is configured using a Crontab file. There are two types of Crontab files on a Linux system. The first is the system-wide Crontab file located in the directory etc. Processes scheduled at the system level are intended for maintenance of the entire system. The only items we see here are for Anacron. Anacron is an anachronistic version of cron. Normal cron assumes that the machine is running 24 hours a day, 7 days a week. If, for example, you shut down your computer at night or on the weekends, some cron jobs won't be run. Anacron, on the other hand, accounts for this and does the best it can to run processes on a set schedule. Here, we can see that Anacron can run processes either hourly, daily, weekly, or monthly. To set up a process to be run, you simply need to place a script in the appropriate directory. Here is an example of what etc cron daily has. Notice that every script is owned by root, since these are associated with system-wide processes. Unless you are an administrator, you probably won't need to configure system-wide cron jobs. However, you can create cron jobs for your own personal account to do things like back up your home directory or change your background periodically. To edit your own personal Crontab file, use the command crontab-e. This will open your own personal Crontab file in a text editor. If you have never run the command before, it may prompt you to choose your preferred text editor. I'm just using Nano since we don't need anything complex. At the moment, we don't have anything in our Crontab file. The last comment in the file tells us the format for each scheduled task. The first column is to configure the minutes and takes a value from 0 to 59. The second column is hours and takes a value from 0 to 23. The next one is the day of the month, which takes a value from 1 to 31. The next column is the month, which takes a value from 1 to 12. The next column is day of the week, which takes a value from 0 to 6, with Sunday being day 0 and Saturday being day 6. The last column is the command we want to run according to our schedule. Let's try some examples. For the moment, I'm going to use a simple command that touches a text file so we can see a timestamp. Let's say I want to run the command at 1:05 in the morning on the second day of each month. To do that, I would set the following schedule: 5 for the minutes, 1 for the hours, 2 for the day of the month, and then every month, so I use an asterisk, every day of the week, meaning we don't restrict it to be on a specific day of the week, and then the command, which will be touch home bob cron tab ran.txt. Remember, all this does is update the timestamp of the file. If we wanted to run the command at 1:05 a.m. and 1:05 p.m. or 13:05 using a 24-hour clock, we could add a 13 to the hour column. Since I don't feel like waiting a few weeks for this to run, let's change it so it runs every 5 minutes every day. It would be tiring and error prone to list every 5 minute increment in an hour. Luckily, cron has some special syntax we can use. If we want it to run every 5 minutes, we can write it like this: asterisk slash 5. Think of it as dividing by 5. Then I can change the hour to be an asterisk so it runs every hour, and the day of the month to be asterisk so it runs every day of the month. Let's save and exit it. We can check that we saved it properly using the command crontab-l. We can see it listed. Let's verify that the file doesn't exist yet using ls. Make sure the directory is empty. So the file doesn't exist yet. I'm going to wait here a moment while we wait for the cron job to be processed. I've waited a while. Let's see if it ran. We can see the file now exists and the time matches an every 5 minute cron job. If we were to wait longer, the timestamp would be updated again to 5 minutes longer. Now that we are done with the task, we can use the following command to delete it: crontab-r. To confirm that it was deleted, we can list all the jobs for our cron tab. There are no cron jobs left. This was a simple example, but hopefully it gives you an idea as to how cron jobs are scheduled so you can schedule your own jobs on your system. While Crontab is useful for scheduling processes to run at specific times, we often want processes to run when the system boots. On operating systems such as Microsoft Windows or Mac OS, this is managed through a GUI. On Linux, it is done by first adding a startup script to the directory etc init.d. Here, you can see that there are scripts for starting processes related to cron. Sound is the also utils, printing, which is cups, the desktop manager, in this case, LightDM, networking, time synchronization using NTP, and many others. All of these scripts were added by the system, but we could add our own if we wanted. Once a script has been added, we need to configure it so that it runs when the system boots. If we look at the etc directory, we see that there are a number of directories that start with RC. Each one of these directories refers to what is called a run level. When you boot a Linux system, you get to choose a run level. For a desktop system, we normally boot using run level 5. This means we boot using a graphical login with networking enabled, and the system allows multiple users to be logged in all at the same time. Servers usually boot using run level 3. This is basically the same as run level 5, but without the graphical login. If you ever need to debug or try and fix a corrupted system, you may boot into run level 1. Since this system is configured for use as a desktop, let's look at the configuration for run level 5. First, notice that all the files in the directory are symbolic links to the scripts we saw in etc init.d. Next, all of them start with either an S or a K. The S indicates the script should be run when the service is being started, and the K for when the service is going to be stopped or killed. After the S or K, we see a number. The number is used to tell the system the order in which the services should be started. These all have the number 1, which indicates that there isn't a preferred order. Sometimes, however, you will see different values since one service may depend on another service already running. You probably won't manage startup services often, but it is important to know how they work for both troubleshooting and just general knowledge about how your system works.